To find the B matrix of this truss, we have to apply F1 as 1 and F2, F3 as zeros and find the first column of B matrix by identifying the member forces from P1 to P7. Similarly, for second column of B matrix, I will apply F2 as 1 and I will find the P1 to P7, so that will be the second column of the B matrix. Similarly, for third column of B matrix, I will apply F3 as 1 and find the member forces from P1 to P7. This is how we establish B matrix. I will apply my F1 as 1 and find the member forces from P1 to P7. In this case, this unit load is acting at a distance of 1.5 meters from the left support and 4.5 meters from the right support. So the value of this support reactions will be 1 times 4.5 by 6 on the left support, and its value is 0.75, and in the right support it will be 1 times 1.5 by 6, and that will be 0.25. Once I know the support reactions, I can estimate the values of the member forces either using method of joints or by using method of sections. In this particular case, I will use method of joints. So in method of joints, you have to consider each joint and apply the equilibrium equations. To choose a joint, you have to check whether there are only two unknowns. I will start with the joint 1. In joint 1, I am having a vertical support reaction of 0.75, and there are two member forces, P1 and P3. Since the known force is acting upwards, the other vertical forces, the only other vertical force is the vertical component of P3, so that is supposed to act downward. This P3 sine theta must be acting downwards. So the direction of this P3 is towards the joint. To find the value of P3, my P3 sine 60 degree is equal to 0.75. So P3 will be 0.75 divided by sine 60, and the value is 0.866. So here I will have a value of 0.866. Similarly, this is acting towards joint, we know that, and the horizontal component of P3 is acting towards the joint, which is P3 cos 60 degree. So this is acting towards left, so P1 must be acting towards right for equilibrium. So P1 is acting away from the joint, and the value of P1 is P3, which is 0.866 cos 60 degree, which is 0.43. So here I will have a magnitude of 0.433. Now I will consider the right support. In the right support, I am having a vertical reaction of 0.25. Here the reaction is 0.25, and there are two member forces, P2 and this will be P6. For vertical equilibrium, the component of this P6 must be acting vertically downward, since this 0.25 is acting upward. So P6 sine theta must be equal to 0.25. 0.25 divided by sine 60 degree will be 0.288. P6 is acting towards the joint, so this is towards the joint. The value is 0.288, and the horizontal component of P6 is acting towards right. So the only other horizontal force is P2. This is supposed to act towards left, and P2 is equal to, this is P6 cos 60 degree. The value of P6 is 0.288. 0.288 times cos 60 degree is 0.144. So this is 0.144, and the P2 is acting away from the joint. So P2 is acting away from the joint. Next, I will choose the joint 5 that has the least number of members. So in joint 5, we are having three member forces. Joint 5, we are having a force acting towards the joint, which is 0.288, and we are having horizontally P7 and another inclined force, which is P5. So for horizontal equilibrium, now we will consider the vertical equilibrium first. For vertical equilibrium, This point, the component of 0.288 is nothing but 0.288 sine theta. This is acting upwards. So to compensate this, P5 must be acting, the component of P5 must be acting vertically downward. So vertically downward, I will have P5 sine theta. So P5 should act towards downward. So it is acting away from the joint. So away from the joint, I will have P5 and its value is 0.288 sine 60 divided by sine 60, which is 0.288. So here the value of P5 is 0.288. And let me consider the horizontal forces. For horizontal forces, there are three forces in this case. One is P7, which is acting in the horizontal direction. The component of P5 is acting towards left. Towards left, I will have P5 cos 60. This is P5 cos 60. And the 0.288, the component of 0.288 is also acting towards left. This will be 0.288 cos 60. Both these forces are acting towards left, so P7 must be acting towards right, which is towards the joint. So towards joint, I will have my P7 and its value is 0.288 cos 60 plus this P5 cos 60. P5 is also 0.288. So again 1.288 cos 60. The value is 0.288. So the value of P7 is 0.288. I will consider joint 4. At joint 4, I'm having unit load acting vertically downward, and the P3 of magnitude 0.866 is acting towards the joint. Towards the joint, I will have a force of 0.866, and horizontally, I'm having 0.288 acting towards the joint. So towards the joint, I'm having 0.288, and there is an unknown force P4. So I will assume the direction of P4 as acting away from the joint. I will consider the horizontal equilibrium. So the horizontal component of 0.866 is towards right, and its value will be 0.866 cos theta. 0.866 cos theta is 60 degree in this particular problem, and this 0.288 is already horizontal. It is acting towards left, so I will consider minus sign for that. Minus 0.288, and this P4, it will have a horizontal component acting towards the right, so it will be plus P4 cos 60 degree, and sum of all these forces must be equal to 0 for joint equilibrium. Now the value of P4 will be, I will take all other forces to the right hand side, so it will be 0.288 minus 0.866 cos 60 divided by cos 60, and the value will be minus 0.288. We are getting a minus sign here because our assumed direction is not correct, so I have to reverse the direction. P4 is acting away from the joint, that is our assumption, but we are getting a minus sign, so P4 is acting towards the joint. So towards joint, I will have P4 with a magnitude of 0.288. All the member forces are known now, so I can write the first column of my B matrix. So the first column of my B matrix will be 0.433. Here it is 0.433, 0.144, then 0.866. Then the remaining forces are 0.288, 0.288, 0.288, 0.288 and 0.288. I have to write these things in the sequential order because this force is my P1, this is P2, this is P3, this is P4, P5, P6, and here I have P7. In the same order I have written this. For the sign convention, my 0.43 is acting away from the joint. So any force acting away from the joint is considered as positive. And 0.144 is also acting away from the joint. 0.866 towards joint, then this 0.288 towards joint, this 288 away from the joint, this is towards joint, so minus. At the top chord also it is towards joint, so it is minus. So this is the first column of my B matrix. For the second column of my B matrix, I will apply my F2 force as 1. F2 is acting at joint 5. I will apply that as 1 and find the value of support reactions first. Here the value will be 1 times 4.5 by 6, so it is 0.25. And in this support it will be 1 times 4.5 by 6, it is 0.75. When we look at the first case and this particular case, these two are actually symmetric to each other. These two are symmetric, or the second one is a mirror image of the first one. We can have a mirror line here. If this is a mirror line, and these two are mirror images, so the forces will also be mirrored. Like near the mirror I will have 0.144, so this value is 0.144, and away from the mirror I have 0.433, so here also away from mirror I will have 0.433, and this force is 0.288, and this is also 0.288. Here also it is 0.288, top chord also it is 0.288, and the inclined member away from the mirror is 0.866, so here it will be 0.866, and the signs will be remaining the same. 0.144 is acting away from joint, so this is away from joint. 0.433 away from joint, so this will be away from the joint. Here this 0.288 towards joint, this will act towards joint, and this 288 is acting away from joint, so here it will be away from the joint. This 288 is acting towards the joint, so here it will be towards the joint. 0.866 is acting towards joint, so this will act towards joint, and for the top chord it is acting towards joint, so top chord towards joint. And the second column of my B matrix, it will be 0.144 is the P1 here, P2 is 0.433, 0.433, P3 is 0.288, 0.288, P4 0.288, P5 is 0.288, P6 is 0.886, sorry 0.866, and P7 is 0.288. For signs, force acting away from joint is positive, so this is positive. 433 is away from joint, so positive. This is acting towards joint, so it will be minus. P4 away from joint, so plus. P5 towards joint, so minus. P6 towards joint, so it will be minus, and P7 towards joint, so this will be minus. So this gives the second column of my B matrix. For third column of my B matrix, I will apply F3 as 1 and find the member forces. Here this unit load is a symmetric, so the support reactions will also be symmetric. The half of 1 is 0.5, so the left support reaction will be 0.5, and half of 1 is again 0.5, so that will act on the right support as well. And as usual we have to solve for member forces. This 0.5 is acting upward, so the component of P3 must act downward. So this is the sign for my P3, and its value is 0.5 divided by sine 60. So 0.5 divided by sine 60 is 0.577. So this value is 0.577. This is acting towards left. So here the force should act towards right or away from the joint. So here also away from joint. Component of 0.577 is 0.577 cos 60. So it is 0.288. So here the value is 0.288. This particular structure is a symmetric about a vertical axis. So the forces in the left will be the same as that of the forces on the right. So here I will have 0.288, and in this inclined member I will have force towards joint, the magnitude of 0.577. So here it is 0.577. Now I will choose either joint 4 or joint 5. Let me consider joint 4. In joint 4 I'm having this P7, P4 and P3. P3 value is known here, which is towards the joint 0.577. I will consider the vertical forces. 0.577, its vertical component will act upward, so the vertical component of P4 must act downward. So now I know the sign for P4. It is away from the joint, and the vertical component of 0.577 is 0.577 sine 60. Vertical component of P4 is P4 sine 60. So the value of P4 will be 0.577 sine 60 divided by sine 60, which is nothing but 0.577. So P4 away from the joint, having a magnitude of 0.577. Since because of symmetry, this force will also be equal to P4. This will be 0.577. So the horizontal component of these two forces, 0.577, both are acting towards right. So 2 times 0.577 cos 60 will be equal to P7. These two forces are acting towards right, so P7 must act towards left. Towards left in the sense towards the joint. So P7 is acting towards the joint. And the magnitude is 2 times 0.577 cos 60 will be 0.577. So here also I am having 0.577. So the third column of my B matrix, will be P1 is 0.288, P2 is also 0.288, P3 up to P7, they have same magnitude of 0.577 each. After writing all these things, I have to find the sign for this. P1 is acting away from joint plus, P2 away from joint plus, P3 towards joint, so minus, P4 away from joint plus, this is P4, P5 away from joint, so plus, P6 towards joint, so minus, P7 towards joint, so minus. You can also have another check. This is similar to a simply supported beam carrying a concentrated load at the central span. It will bend like this, so the bottom members will be in tension and top member will be in compression. Like here we can see the negative sign indicates compression. Now I have values for all the 3 columns of my B matrix. So my B matrix is complete.